Okay, so we're getting towards the end of the semester. Our penultimate task we're going to talk about is the visual world paradigm, which is a version of eye tracking. So, to orient ourselves, we're looking at more psycholinguistics. Psycholinguistics, as I said last week, is the study of processing or real-time language use. Eye tracking is particularly a version of parsing. Self-paced reading time was the first psycholinguistic task that we looked at, and visual world paradigm, which is a version of eye tracking, is the second. Eye tracking can also do sentence reading, which is more like self-paced reading, except for with different kind of measures. Now we're going to talk about eye tracking more generally, so you'll be able to perhaps correlate what I'm talking about with that, but if you have specific questions about reading sentences, and we'll look at an example. But if at the end of this you find you don't want to know more about the relationship between self-paced reading and eye tracking, just shoot me an email because there are connections to be made. Now, eye tracking in general, here we're seeing a calibration screen on an eye tracker, and I'll explain to you what that is in just a second. Um, Eye tracking is recording gaze data with respect to an image on a screen. There are other kinds of eye tracking, like things embedded in glasses and such, but it's not really used in research up until this point, at least not linguistic research. So we're going to set that to the side. They do exist, other types of eye trackers, but the vast majority are kind of like this. Well, this screen is kind of like a screen mounted. It's got a bar. So the thing below the screen you're seeing here on the right, this is essentially a mounted bar, which has a little light in it, okay? And what it does is it shoots a little light that reflects off of your eyes, and then it calibrates by having you look at specific spots on the screen. So for example, in this here, you see a red dot and some white dots. Now let's imagine I've said, hey participant, look at that red dot, and I'm bouncing a light off your eyeball. And the way that it reflects, it's going to go, well, that must be how it reflects when I'm looking at that part of the screen. And so then it takes recordings, or essentially measurements, based on different points in the screen. So this middle top is what we're looking at now, but then you might have to go top left, and top right, and bottom left, and bottom right, dead center, or something like that. And it takes measurements in all those points to kind of get a baseline. So it can compare what measurement and the exact details aren't that important, but the measurements that it's getting off of your eyeball, it can estimate it based upon those preset points to make a guess about what you're looking at later. So as I said, then you calculate gaze position for the gaze data during the experiment. And when I say gaze position, it's just what are you looking at? We call that, gaze, right? What am I looking at? And there's a duration and there's a position, okay? Now, eye tracking is about attention. Typically, we talk about it in that way. It's been proposed that it's a measure of attention, eye tracking is, such that if a participant looks longer at something or more times at something at a screen, we say they're paying more attention to it. And then we draw conclusions about why would you pay attention, or why does that matter? It relates in a small way to what's happening in self-paced reading, and I know you said you can contact me, but I'm just going to point this out here, is that duration is a very common psycholinguistic measure, in the same sense that if you're doing a self-paced reading and you pause in the spillover region going, wait a minute, it's similar in concept to your eyes spending more time going, wait, look at that part of the sentence, look at that part of the picture, whatever. That sort of duration, that like longer attention is interpreted to mean something. So measurements of eye tracking in particular include first fixation, so how early you look at something, the number of fixations, so how many times you look at something. So if I'm reading a sentence and I go back and read the same word, I read the word the, and then I read the rest of the sentence and come back to the, and then the, right? That's how many times I've looked at it. And then total duration, so how much time in total I've looked at it. These are pretty typical. So what they're trying to do is what draws your attention first, what draws your attention repeatedly, what draws your attention the most in total, okay? And depending on what kind of experiment you're doing, people tend to find one or more of these more important. We'll see from the article, our reading today, which one they were talking about. What kind of questions can I ask then with eye tracking? How about this one? So do participants look longer at a critical word in a sentence that contains an error as opposed to a similar item without an error. So compare numbers 1 and 2 here. Number 1 is grammatical. The men looked at themselves in the mirror versus 2, and the asterisk of course means ungrammatical here. The men looked at themselves in the mirror, which should be plural. It should be like number 1. So my question is, do they look longer at themselves compared to themselves? Okay. Now, presumably you're not going to look there faster because you're going left to right, right? But you may look at it more times. You may look at it longer. You might go, hey, that doesn't make sense. You might actually go back and look at the antecedent, at the men, like, oh, wait, that's plural. What happened here, right? And those are the kinds of measurements we're doing in eye tracking. And this is sentence reading at least. So the hypothesis would be participants will look longer at themselves than themselves because themselves doesn't agree with the men. Okay, or you could say they'll look back at the men more in number 2 because they'll be saying, hey, it's supposed to be plural, you know, those kinds of hypotheses it could make. Other types of questions for eye tracking pertain to today's task, in particular the visual world paradigm. On the right, you see a little clip from the article that was actually relevant to the quiz questions, which we'll get back to in a second. And here I see a visual world, right? It's an image, well, it's a space in the screen, it has images. So that thing on the right, that box, that would be an entire screen. And in one corner you would see a goat, and the next corner you would see a piano, and then you'd see a hammer and you'd see a trumpet. Now I'm going to ask you to think about this for a second, and if you read the article, as I hope you did, you'll notice that some of these are more related than others. In particular, the 2 on the right are musical instruments. So, if I ask, when presented with a semantically related picture, does it compete for attention with a target item? So if I'm trying to get you to look at piano, but one of your other items is a trumpet, is trumpet going to compete for your attention because of the semantic relationship between piano and trumpet? So what's happening here is maybe you hear, click on the piano. This is a very typical visual world paradigm procedure. Click on the piano. And as they go to click on the piano, their eyes are going to flick through the pictures and figure out which one makes the most sense. And it's going to flick between all of them at some point. And then it's going to settle on the one it's going to click on, because attention, you know, the clicking, you're going to look at what you're going to click on. Your attention is focused on the correct picture, but not immediately, right? So the hypothesis is participants will look at a semantically related picture, aka the competitor, more than the distractors, but less than the target item. You also could say they'll look at the semantically related picture longer, or something like that. Now, as I said, we're going to assume target is the piano, because I said click on the piano, and our competitor here is the trumpet, okay? So, as I said, this is called visual world because it's kind of like you're supposed to be looking at a table of stuff. I think that's the idea. It's supposed to have some spatialness to it as if you're physically in the room. The other items are fillers, typically is what they would call them. In this case, the goat and the hammer. And the competitor can compete in various ways. The one I've already mentioned is semantic relatedness, right? So here they're both musical instruments. But phonetic overlap is another huge one, right? So if I had a pizza on there and nothing, so instead of a trumpet there was a pizza, and I say click on the pizza or click on the piano, since I have to parse left to right essentially from the onset of the word, I hear p, okay, that's true for pizza and piano. I hear e, that's true for pizza and piano. Depends how you say piano, but it's fine. And then the piano, or the actually a piano, you go, huh, it's not pizza, right? And so that's a competitor phonologically or phonetically, really, okay? If you're in a language that has genders, so let's say German has 3 genders. It has feminine, masculine, and neuter. And your target item, you marked it with the word the. The, in a lot of languages, depending on singular versus plural and all that, it gets marked in German too, right? I don't know those words off the top of my head, but say the marked for feminine, the marked for masculine, the marked for neuter. And you hear click on the, and the is marked with gender. If you had 2 things of the same gender, that would be a competitor, right? Not so eventually you would say piano, and there's something else of the same gender, it would compete with piano at least throughout the duration of the. Okay, so these are kinds of competitors that you could have in a visual world. Now the reading quiz made reference to two parts of the article. And I'm going to show them to you here, and this is actually the last piece of this video. So, and this, to understand this is to kind of understand how visual world works. What you're seeing again on the left is the sample with the competitor in it. In figure 1, they had one where there was just the target, one there was just the competitor, and one where there was both. The first two are kind of strange because you really don't typically look at any that don't have both. And in fact, in figure 2, you had attention, essentially gaze data for all three of those. But we're going to hone in on target and competitor because it's really that relationship that matters in the end. So, of the three conditions, the third one was target plus competitor. I think it went target, competitor, target, competitor. And then again, target, competitor, then target, competitor in figure 2. This is where we have target and competitor. So essentially, this is where I'm saying click on the piano. What you're seeing is on the left, and on the right is the gaze data. To orient you to this, I'm not sure what they're doing with the negative to the positive. Let's say that um, it depends on how you code it, whether you could have negatives in this sort of sense. But let's say that um, 0 is average. It's like a z-score or something. And -2 is nothing at all. However, the data is coded. But let's say up is a lot of attention and down is none, right? And where the distractor is over at 800 milliseconds, let's say is nothing, for example. Let's just estimate that. So what I'm looking at is gaze data on the y-axis. How much? A lot to nothing on the bottom. And on the x-axis, I'm looking at time, right? So when I first say it is at 0, 100 milliseconds, 200 milliseconds, 300, up to 800, okay? So this is as time is going on. So then we have the proportion of how much they're looking at each thing at the different time intervals. They're kind of buckets, if you will. And you'll see that at the onset of click on the piano, there's a time period where the participants are looking at all things, right? And here they've clearly collapsed the goat and the hammer into distractor. But as they go on, somewhere in the 300 milliseconds range, we're seeing a split where the distractor is starting to fall away, but the competitor hasn't totally been discounted yet. So they're still looking at the competitor more than the distractor and less than the target. And as time goes on, that distinction only gets greater and greater and greater, right? But the proportion that the target, that the competitor is looked at compared to the distractor, in this case, is still higher, but it's nowhere near the target. A lot of times, what you end up seeing is the category, the competitor and the filler end up flatlining. So it depends on how this data is coded, but we can basically imagine here that it's flatlining, that they stop paying attention to it altogether. And eventually the thing that you click on, and they haven't said in here that they're clicking, but that's a very typical thing. So we're going to pretend that that's happening just for the sake of argument. But as you go to click on it, usually you stop looking at everything else. And this is pretty typical, right? This competition model. And so here we're using either proportion of gaze or total gaze duration to indicate attention. Okay, that is visual world paradigm.